Hi, so streaming should have been started now, and let me just quickly check. It is streaming, right? Yes, it is. Just get this over here. Oh God, I can't get this over here. Okay, get the chat out. Oh, I had a lot of assignments pending, and I just got one of them. I think this is gonna be a short stream. I'm just gonna do some lead code questions. Uh, that's fine, that's fine. All this is working. And we should be good to go. All right, so we're just gonna do a couple of questions from lead code, and I don't feel like doing very hard questions, but we'll see. I don't have a notebook with me right now. Gotta do something about them, but we'll try and just do it on Excalibur, whatever we're thinking, right? That should work. And let's start. So I've been doing questions from this list of questions. Right. I've got a lot of questions remaining from recursion, and these are all hard questions, so close them. Okay, generate parentheses. N pairs of parentheses, write a function to generate all combinations of well-formed parentheses. So, valid parentheses, it should open and then close, right? Uh, hmm. And you gotta solve this recursively. Let's start with what I do know. There's gonna be a answer, and I'm gonna pass that to a function, right? So because I'm obviously gonna have to create a function. So let's start with that. Pass it by reference. All right, so we're given n. We need to pass that in. Right, if n, there's a base case, right? What's the base case? If n is equal to 1. Hmm. So when you got a parenthesis, it can do two things, right? Okay, I think I've got some sort of intuition. So it can do two things. It can either close itself on its own like this, or it can enclose other parentheses. Right. So if it does this, then well, we've got a tree now. So if n is equal to 3, well, it can do either of these two things. All right. Well, I need to get this. Anyways, so suppose it closes itself, right? And that's a part of a string, and n equal to 2, because we need to get to the base case. So we're gonna have to subtract. That's a mosquito right there. And if not this, then, well, I'm gonna add this to the string, do a bunch of shit, and then when it's coming back, then we add this, right? And again, right. N equal to 2 again, right? So this again can go one of two ways. Let's add this to the string, completely closed on its own, and add this, right? And then when it comes back, I'm gonna do that, right? When it comes back, then I'm gonna add this like that, right? Two, right? Then again, so n equal to 1 right here, right? And then we go down here, so we get these, or we get these, and n equal to 0 right here. So when we call n equal to 0, we call it with 3, and then it does this. So 2, it does this, and then we call it with 1, it does this. When we call it 3, it does, well, it's gonna add it to the string, right? It's gonna add this, push back, whatever. So this is the base case. This is the base case, and well, we've got these. It's the base case, so it's gonna end up adding this, which I do not want. What I can do is if the length of the string is, well, it's what, odd str length, odd, then don't do anything and then return the call. Right, it's gonna return the call. It's gonna add this I think there's something missing with my logic. I need to I need to draw out these. Right, so these go one of two ways. Uh, and then these go one of two ways. I think I'm on to something. I've got a little ways to go. It's gonna let me finish solving this. Okay, let's just if n is equal to 0, because it's called with 3 first, and then does this, and then it's called with 2, and then it's called with 1. And then add to the answer len is even, add to answer with len is odd. Maybe that. I'll need to figure out the base case correctly. I've not figured it out because then this gets added twice and I don't want that. And then we're gonna, well, it's already been 10 minutes. Well, self-enclosing, completely closed case. Right, so I need to create a new string, right? Right? I'm not sure. I am not sure at all. Wait. Oh, messed up my setup a little bit. Just gonna. Give me a second, guys. Okay. I need to. All right, so it's the completely closed case. Let's do that first. Just add it to the string, and then I need to pass the string along because then, all right, it does this, and then I call it again with helper n minus 1 ans cur, and then I need to reset the string. Uh, Again, I need to reset the string curve plus this helper n minus 1. And then helper n minus 1 answer current. No, I need to pass in second string, right? And then what this, then I need to uh, okay, so it's either this or I think I should just add like two of these. Maybe that's gonna help. So it's either this or it's either this. But then I end up with a case that's completely like this 3 times, and that's not okay, right? Because no, we're not rich yet, friend. It's gonna take a while. Gonna take a while of this head banging. Uh, Man, I think I'm stuck. Cur plus this, and then I call the helper function again. Uh, and then write a function to generate all combinations of well-formed parentheses. So this does this, and then it's at 0. You can do guest appearance, yeah. But the thing is, can you solve this question? And then maybe you can get rich. Uh, okay. Let's analyze what I'm doing right now. So I go call this function with 3 answer and a string that's empty. And it's not 0, so it goes there, adds these to my string, calls it again, and then it adds these to my string, and then calls it again. And it's like 2 answer and this, and then adds this again. So we're here, and then we call it with 1 answer and then string, and then it adds this, and then it calls it with 0 answer and string, and then I add it. Let's just build it one at a time. So it's ns dot push back curve, right? Okay, so we've added this, and then It goes right here, and n is 1, and my string is two of these. Uh-huh. This shit's weird. How the fuck am I supposed to? So the string that's passed to the base case looks something like this. And it, we've got n equal to 3. I think we can check something along those lines, string length and n equal to 3, which will give me 2, 3, 4, 5. Uh, so n equal to 4 as this as one of the valid parentheses. And shit's this shit's tough. Almost, we're at 20 minutes now solving this one question. Should I give up? I feel like giving up. Is there a hint? It's got DP, backtracking, all that good stuff that makes a man go crazy. Hmm. Yes, we go back and then we remove this. Is that it? Oh, we can get two strings, right? Okay, okay, I think I'm on to something. Instead of just one string, we can have two strings, right? So string revive is equal to another one of these, and I pass on the left and right. Okay, so there's two cases. If it's the completely closed case, then to the left string we add, and if it's not closed, then we add this to the left string, and then this to the right string. Right, do you guys see what I'm getting at? You probably don't right now. Okay, so now we've got two strings. So if it starts at, okay, no. So we start with this, right? Left and right. Now let's just write out the function call. This is the function call, and what it does is, well, it goes left equal to, because it's not 0, right? It's 3, it's not 0. It goes left equal to this. No, wait. And then right, I think someone's at the door. Just a second, guys. All right, I'm back. Yeah, so this is the left string, and my mouse is charged a little. It's nice. This is the left string, and the right string is just as it was. It's empty. It's still this, and I'm gonna call it with 2. Right? And another thing, the other function I'm gonna call is this. Uh, and this, right? And then these get called again to something that looks like this, 1 comma, nothing, and then again, and just draw big boundary right here. This gets called with this. Right? And then these, get rid of these. These get called with hey, hey, hey. Right. And then I add them. And then another function call that is the same as this one, right? This is the same. God, I need to make this smaller. Oh, just make this smaller. Just draw it out. 0, comma, this, a very bad bracket. Now that's some genius level. I think I'm onto something now. Well, something that was better. I was onto something earlier too. And then you add left and right, but then it's, well, it's not. Not exactly unique now, is it? Well, I'm just gonna create this function and then let's see where we can go from there. So doing this destroys my left and right string. I'm just gonna add the helper function without modifying the string. So that's n minus 1 and ans left plus this comma right. Remove this. That's helper n minus 1 ans left plus this right plus uh and now we need to push back left plus right. Oh God, not even fucking 20 lines of code. It's like 30 minutes already. Let's try and run this. It's gonna be wrong because, well, memory limit exceeded. Oh God. Hmm. Why is the memory limit exceeded? Man, thought I got it this time. Well, I'm just gonna try and running it in VS Code. Because I want to see if this uh, using namespace. Obviously, why is this not installed? Okay, class solution. Hmm. I'm just gonna take these out here. Seg for it. I don't even have C++11. Amen, nice. Why do I get a seg fault? I don't get it. 3. I don't get this at all. I'm gonna only add an opening parenthesis. The number of opening is less than n. Parentheses are balanced. For generating while parentheses, you should only push the result when the number of numbers. Man, that's just a shitty. I don't even think that's correct. Is it? I don't think that's correct at all. See, it's just gonna generate these, which is fucked. It's not the answer I was looking for. Seg fault. Termination condition of the question and becomes negative. I did. Oh, no way. I did. Oh, this hurts physically. I hate my life. Where do you go? I don't. So what? What? Expected these. What can I say? And then it's the opposite. Then Don't tell me this works because I have no idea why it will work. I'll be see. Okay, that's what we're missing now. This we don't have these. Okay, I think I'm gonna give up now. Ah, 40 minutes on a question. What can I say? Class equal to question problems for any given n, let's say n equal to 2. We have to fill 4 places in our output. We have two choices and one decision to make. Our choices are to either use this or this. Now let's try to visualize recursive tree based upon the choices discussed above. Initially we have for n equal to 3, current output equal to this, available open bracket count and available close bracket count. The first choice is simple. Since we cannot start a balanced parenthesis sequence with close bracket, we have only one choice in the beginning. So our output will be opening bracket and count of open brackets left equal to 2 and count of closed brackets left equal to 3. Right. Output input. Oh God, this guy. Open, closed, 3, 3. Open 2, close 3. Okay. Uh, right. So it's a simple case that closed must be greater than open. Right, okay. And then I wonder if you know what it means to find your dreams. And I wonder if you know what it means. Find your dreams come true. Open equals 0, close equals 0, start push back string. And this is like 2 minutes. Okay, that's one answer. A backtracking solution. We know we gotta do. close in max. String dot length equal to max into 2. Open is less than max. What do you mean? It's gonna be less than max. Oh, counts number of open brackets right now. It's closed like that, and then okay, that's I get it now. Where is it backtracking? What is backtracking? Oh, holy shit. That took a while. And I gotta reset all this code. I don't like doing this. I don't like Leetcode at all. God. Man, I don't wanna write the code out. I hate this. Oh, vector. And well, we've got in left count, open left, or make it open left, and closed left. And then these, right here. Open left, close left, and now well, if I need a string too, right? Curve dot, no, I can just do this, right? Open left, well then friend, you push it back to our vector array and you return. Okay. It was gonna post decrement it, that would have been a problem. And open left minus one, uh, close left stays intact, current plus this if closed left is greater than open left, right? Because if they're equal, then I don't want it going for the closed first in any case. Then we go with the helper n ans open left. It's gonna go there first. I'm just gonna call it again. Go, go, go. Comes to 0 and checks if this is greater. It is. And then on the closed left. Closed left. And then it's 1 and 0. And then this returns right. And then it returns from here again. And then we return to what call? Return to a call where what to open brackets. I think this should be it. I need to check. It's the how is it even added? Same with this one. Right? Man, I wanna go kill myself. Can I go kill myself? I hate this. I fucking hate this. I fucking hate recursion. I don't want anything to do with recursion forever in my whole life. What the fuck? Fuck this. Fuck this question. I'll solve this once. Hope I can solve it again. Why is this not ticked then? Well, I don't know. When did I solve it? A day ago. What? Oh, I solved it with, well, I solved it with bit manipulation. So like, so if all of these are one, then you take all the elements, and then if it's 101, you take the first and the last element, and then 110. So you can just use all the numbers from 0 to 2 raised to the power n. That's the size of the array minus 1. Now I gotta do it with recursion. So let a power set of all of them. Uh-huh, uh-huh. Holy shit, I type a lot with this keyboard. Vector, vector int ns, helper function, call it with ns, and nums obviously, and then return the answer, create a helper function, void helper, but it takes a vector int for nums, and it takes a vector int called answer, and I pass it by reference, and I start writing the function out. So if, well, you can either take the element or you cannot take the element. That's how power sets work, right? So we're here and you either choose this element or you don't choose this element. Right. Base case, if this, then this. Choose the element. Don't choose the element. Do either of these. So how do I track which element I'm on? How do you track which element you're on? But first I need to get a set. Pass and set to the parameter. Index next starts at 0. If you choose the element, then set dot pushback index. Or I don't choose the index. I need to remove it. Not even set vector. There is a method called pop back, right? The last element. Yeah, I cannot do exactly that. If index is equal to nums dot size plus 1. Oh God. Well, if it's equal to nums dot size plus 1, I'm cooked. Honestly, I'm mentally cooked. Right? Because it's gonna add the last element and then it's gonna add 1. It's gonna become equal to nums dot size. Then you nums dot push back this son of a gun to what son of a gun set. And you return. And that should be it, I think. Please work. Oh, yes. Answer or pushback. Set or pushback nums index. Uh-huh. Heap buffer overflow. So, alright. No, I need to. Yes. I don't know why I did that. Did I actually get it right? Oh God. The most optimal recursive solution. It is optimal for this problem. Oh, 2 raised to the power n into n means it takes up to n time to copy into answer. Yes. Space this for storing all such sets. That makes me happy, well. Actually does. Learn all patterns of subsequences. That's theory. Generate all binary strings. They removed all the geeks for geeks questions from here for some reason. I have no idea why they would do that. Oh, how long is this thing gonna be? I completely missed out on your chat. I got no idea when this came. Is it recent? No idea. Given an integer n, print all the binary strings of size n which do not contain consecutive one. Okay, binary string is that string which contains only 0 and 1. All strings of size n that do not contain consecutive ones. Valid binary strings in lexicographically increasing order. Okay, so It should not contain any consecutive ones. Right, right. Well, let's start with what I know. I know there will be a vector of strings that's called answer. And then I'm gonna call a helper function that's gonna take in said answer along with num. And I'm gonna pass in a string and I'm gonna return the answer. Right. Private void helper void string ns and num. Well, there's a base case. If something, then do something and probably return in the base case. And then, well, there's two things that we can either write one or we can not write one. So that's write zero or write one. Add one to string. I'm gonna add zero first, right? Because I need it in a lexicographically increasing order. Zero to string, add one to string. If current I'm gonna add zero to the string regardless though, right? So just yeah, I'm gonna add it regardless. So let's do that. And so num minus one, car plus zero, and if car dot length zero or so it should not be equal to one because I do not want consecutive ones. It can be zero. Can leave zero. Then you add one to the string. Okay, so what this does is it goes right here, and if curve dot size dot length is equal to no equal to zero, then you do answer dot push back current, make this pass by reference, right? gets called 3. So it's answer 2 plus a string called 0. Gets again answer 1 0 0. Answer 0 0 0 0. Gets pushed back and then gets returned. It's 0 0 right now. So it gets 1 added. Right, and then goes back, returns 0. I think this works. Let me just it works for this, and it hopefully is gonna work for all 20. Let's fucking go. Let's fucking go. Two on the right is essentially optimal for problem solving. You can always add 0. You can only add 1. Ha. Okay, so that worked. Then there's a theory video that I need to watch. Bro, just pause that shit. And anyways, count all subsequences with some care. Given teacher can return the number of non-empty subsequences, array nums of non-empty subsequences of nums such that the sum of all elements in subsequence is equal to 10. And I gotta do it recursively. Fucking hell. Well, I'm not gonna lie, I am kind of tired. And how long have I been streaming for again? I've got no idea, bro. Think it's been an hour. Yeah, I think I'm gonna take a break. Well, let's continue this later in the day. I'll go do some other shit. Thanks for joining if you did. And comment and tell me if you think I can improve on something. And I'll see you guys in a while then.